During this session, you will be learning about signals and Bluetooth. To start, let's go over what a wave is. A wave is a curve that describes a repetitive oscillation and can be written as an equation. This image is an example of a light wave. Now I will go over some measurements we can make from a wave. First is amplitude, which is the height of the wave. A higher amplitude corresponds with a brighter light. Next is wavelength, which is the distance from crest to crest or trough to trough. Changing the wavelength of light will change the color. Changing the frequency can change the color as well. Frequency is how many complete cycles there are within 1 second. One complete cycle is between one point on the graph up until it appears again. Let's say that this whole graph is 1 second long. To find the frequency, we can count how many cycles there are within 1 second. How many are there? Well, let's count. 1, 2, 3, 4, 5. So there are 5 cycles, and thus a frequency of 5 Hertz. Hertz is just the unit we use to measure frequency. Lastly, the phase is the position of a specific point in the cycle of a wave. You can think of one phase as one complete cycle of a wave until it begins repeating itself. Radio waves are one type of light on the electromagnetic spectrum. They have the longest wavelength and smallest frequency. The wavelength of a radio wave can be as long as a building and as short as a coin. A Bluetooth device is one example of technology using radio waves. They transmit data via low-power radio waves in order to use as little power as possible and avoid interference with other signals. When a device turns on Bluetooth, a small chip, as the one we will be using on the left, sends out radio signals to another device that will then respond back, creating a tiny network called a piconet. When a piconet is established, the two devices will transmit data back and forth using radio waves at a frequency of 2.4 gigahertz. A good question to ask is, how is data represented in radio waves? The short answer is modulation. Modulation of radio waves is essentially modifying the wave to represent ones and zeros. Two common radio modulations are FM and AM. They are familiar to you because they are the reason you can listen to music on the radio in your car. AM stands for amplitude modulation, and FM stands for frequency modulation. AM changes the signal by altering the amplitude, while FM alters the frequency. As you can see on the right image, a change in amplitude for AM and a change in frequency for FM both result in an inputted signal of 1. When the signal is constant for either, the input would be 0. These 0 and 1 inputs can be thought of as on and off switches, and are the foundation of how computers and electronics work. Bluetooth signals work a little differently. They send data through phase shift keying, or modulating the phase of the wave. A phase shift is when a specific point of a wave is altered to a different moment of time on the same wave. As you can see on the right, the ones occur when the signal has a phase shift until it shifts back into the original phase. The specific signal is represented by ones and zeros for every 2 phases. These combinations of ones and zeros, also known as bits, can represent any information. Here, you can see the alphabet and symbols with their associated binary code. If a computer receives a certain combination of zeros and ones, it knows exactly what value is associated with it. Computers can distinguish between 0 and 1 because they can receive pulses of electricity over a wire. A higher voltage is 1, and a lower voltage is 0. Take a minute to write down your initials in binary. Now you will do a small activity converting signals into messages. This specific signal is a Bluetooth signal because it is using phase shift keying in order to form zeros and ones. In addition, this signal represents zeros and ones by using only one phase. I will do this one with you guys. So let's first break the signal into individual phases. Now we have to find the corresponding bit for each phase. Starting from the left is the original signal, so it must be a 0. Next, as you can see, there is a phase shift, so this means it's a 1. After that, there is a 0, 1, and 0. This is due to the fact that each has a phase shift. Now, the next bit remains a 0 because there is no phase shift. To finish this signal off, there is a 1, then a 0. Take a moment now to use the table of the alphabet in binary to find which letter this signal corresponds with. Have you found it? It is the letter R. Now figure out the letters for the last two signals that will be provided to you. Now you will be completing the last construction of the device. During this construction, you will be wiring the Bluetooth device to the breadboard and Arduino. Connect the VCC on the Bluetooth module to the 5 volts on the breadboard that is established by the Arduino. Also, connect the GND on the module to the ground on the breadboard. Connect the TXD on the module to pin 11 on the Arduino, and the RXD on the module to pin 10 on the Arduino. So now we're going to be soldering our Bluetooth module. There are 6 prongs on it, but we're going to only be using 4. The 4 that we're going to be using is VCC for power, GND for ground, TX for transmitting information, and RX for receiving information. So we're just going to start soldering it onto our board. So let's see where we want to put it. Why don't we put it there? So you can see that the prongs going that way, each one on its different row, so they're not connected at all. So now let's just start soldering it. You don't have to solder each prong, only the 4 ones that we need, but I'm going to be soldering all of them just for keeping it a little steadier so it doesn't fall out. One last one. And because each prong is going to be doing something different, make sure that none of them touch each other when you're soldering them. Oh. Like I just did right there. So I'm going to use some of this to take some solder off. Okay, now it's not connected. Okay. Let's check. So it's all soldered. Now we're going to connect our 4 wires for our 4 prongs. So we're going to use the orange and the 2 oranges for ground and power. So let's start doing that one. So as you can see, we have the VCC here. So if you flip it to the other side, we have to do it to this prong. So put that there and solder that. think that's good. Now this is for power, so we're going to connect it to our power, which is on this side, this long string. So we have to find a place for it. I'm going to actually unsolder one of these holes so we can actually put it there. Take some solder off. There we go. So now we're going to take our orange wire where we just soldered and put it into one of the holes for power. Where is it? There we go. Oh. Put it on this. Now I just have to solder it in place. Okay. Now we're going to do the same for ground, which is right next to the power that we had. So put that there. Make sure they don't touch, but solder it. See, so I'm gonna put it. Actually, that's next to ground, so that'll be actually good. Okay. Now we're going to connect that to our ground, which is actually right next to it. So just put it into one of these holes over here. Move this green wire. So this is ground, and this is power, and we're connecting the ground to this column right here. Okay, now that's all done. Now we're going to be adding our RX and TX wires, which are the green ones, and that we're going to connect those to the Arduino. So where are they? So we have TX we're going to do first. So just connect it. It's going to be right next to the ground one you just soldered. Pull it over. Sometimes it doesn't stick, so you just have to keep on trying. Oh, there we go. Wait, kind of let it cool off first. All right, now it's stuck. And we're just going to start actually connecting the RX one too. So that's going to be right next to the TX. Oh, I got to resolder that one. Okay. There we go. Now we just have to connect these wires to our Arduino, which is over here. And you're going to connect the TX to pin 11 on the Arduino and the RX to pin 10. and then you can just put it into the case. After finishing the construction, you have to code the Arduino to send the data it is gathering from the current sensor to the Bluetooth module. From here, it will transmit that data through radio waves to your computer or smartphone. Now let's start by connecting the Arduino to the computer and running the IDE. Next, copy and paste the provided code into the IDE and compile and run it. The next step is to check if a device can connect to the Bluetooth module. Either use your computer or Android phone to pair to the device. It should be called HC05, and the password will be 1234. After paired, there are a couple ways to view the data wirelessly. If you have an Android phone, there are a bunch of Bluetooth terminal apps that allow you to view and communicate with your device wirelessly. In this program, I will show you one of these called Serial Bluetooth Terminal. After downloading from the Play Store, open it and tap on the sidebar where you will see Bluetooth devices. From there, tap the name of your device and go to the terminal section. The last step is to tap on the connection icon to the left of the garbage bin. You should now see the same data you viewed from the serial monitor on the Arduino IDE. Another way to test your PV device is to run a computer program. There are plenty of ones you can download online, but I personally use one called Bluetooth Serial Terminal. In the specific program, you have to first connect to your device and find it on the drop-down menu. From there, click on Connect and you should see the data appear. The last way you can view the data on the device is using an application I created from MATLAB code. You can find this on our website, where you can view all the other downloads from this program. This application is great because it formats the data into a graph that continually updates. All you have to do is download it and follow the installer process. From there, make sure your Bluetooth device is connected and run the program. Now that you have your device running and paired with either a computer or smartphone, take some time to walk around the room or go outside to find where the most power is being generated. This concludes Session 5 of the Current Solar Panel program. I leave you with this quote: "Truth is ever to be found in simplicity and not in the multiplicity and confusion of things."